Good day, students. On this clip, we're going to be going over examples on how to solve equations with variables on both sides. So the whole idea here is basically um, getting the variable on one side of the equation so that it becomes like the simpler equations that you learned how to solve before. So the technicality here again is the fact that we have the variables on both sides of the equation. Okay, so that's the issue that we're dealing with. We have variables on both sides. So if we can get the variables on one side, it becomes an easier problem that we can do. All right. So the goal is as follows. So number one, you want to basically get variables, get variables on one side, and constants on the other side. Okay, get variables on one side and constants on the other side. Okay, that should be your first goal. How can I get all the variables to be together on one side? They're going to be like variables. When I get them together on the same side, then I can combine them together. So if I have variables on one side and constants on the other side, um, all I just have to do next, I'll combine like terms. If they're not already combined, combine like terms. And finally, I'll just isolate the variable. Okay, whatever the constant is in front of the variable, that's what I'll use to isolate the variable. Okay, so the most complicated part of this whole step process is step one, which is getting the variables on one side and the constants on the other side. All right, because there's a lot of sign flippage going on that you have to keep in mind. All right, so let's try out some examples. The instructions is as follows. Solve each equation. Solve each equation. Solve each equation and check and do a check. Okay, and do a check. All right. So the first problem we're going to try out is the problem 2 plus 5k. 2 plus 5k equals 3k minus 6. All right. So the goal first of all is to get the variables on one side, okay? So the k and the k, those are the variables, and then the constants are 2 and negative 6. So if I can get the variables on one side and the constants on the other side, I can then focus on isolating the variable. All right, so what I'm going to do, I'm going to do a hybrid step. In the following step, what I'm going to do is I'm going to combine steps 1 and 2. I'm going to get the variables on both sides, but while I'm getting the variables on both sides, I will combine like terms simultaneously so that it makes the steps quicker. All right. The less steps you do, the less likely you are to make mistakes. All right. So I don't want us making a mess. All right. So let's try this out. So note whenever you're moving uh, constants or variables or terms across the equal sign, you have to use the opposite, okay? So that you don't change the equation. We have an equation here. I like to move 3k to the left. It doesn't matter where you move it to, you still get the same answer. But I like to move 3k to the left. I like to move 2 to the right, okay? So since this is positive 3k, you don't have any sign here, so if there's no sign, that means it's positive, all right? You can put that there if it helps you, but no sign means it's positive. So I want to move this 3k to the left and I want to move 2 to the right. So I have constants on one side and variables on the other side. Variables on the left, constants on the right. So I want to move 3k to the right. What is the opposite of plus? Opposite of plus is minus, right? So I'm going to subtract 3k from the left. In order to preserve equality of this equation, I'm going to subtract it from the right also. Okay, notice what I did. I lined up like terms. This is degree 1, this is degree 1. Line them up so I can combine them together. All right, this will move 3k to the other side because these two cancel out. Well, simultaneously, I also want to move 2 to the right. Okay, this is positive 2, so I'll do the opposite, which is negative 2. And this one right here, minus 2. You always do the opposite of whatever the sign is on top. When I combine these two equations together, what I'm going to accomplish is I'm going to have the variables on one side and constants on the other side, and like terms would have been combined simultaneously, all right? So I'll draw a line right here and draw a line right here. All right, now how do we simplify this? Well, Um, if the signs are different, what do you do with the numbers? Signs are different, you subtract the two numbers and keep the sign of the bigger one. But these two are opposites, right? So opposites cancel out. So these two just cancel out to zero. Now these two have different signs. So what I'm going to do is I'm going to subtract the coefficients. What's 5 minus 3? It's 2. 2 just bring down the variable, k. Now, whenever the signs are different, you subtract and keep the sign of the bigger one. Which is bigger? Positive. I mean, 5 is bigger, so you're going to keep the positive. So this is going to be positive, all right? On this side, these two are opposites, so they cancel out to 0. Now, when signs are the same, what do you do? When signs are the same, you always add the numbers and keep the sign. Okay, so signs are the same here. You just add the numbers. What's 6 plus 2? 8. What's the sign? Minus. Okay, now notice what we've done. We've got the variables on one side and constants on the other side, and we've also combined them. All right, so we did two steps in one. Now, the last step is to isolate the variable. What is the relationship between 2 and k on the left side? It's a multiplicative relationship. 2 is being multiplied by k. So to undo this, we have to use the inverse of multiplication, which is division, right? So I divide both sides by what? By the coefficients. So divide this by 2, divide that by 2, and I'm going to get k equals 4. I'm sorry, k equals negative 4. All right? So just a real quick note on the side. When you're adding and subtracting numbers, if the are signs are the same, what do? You add and keep the sign, okay? Keep the sign. That's the first point to note. And second point to note is that the signs are different, you subtract, okay? Subtract and keep the sign of the bigger. Keep the sign of the bigger number, of the bigger number. Okay? So that's basically how you do it. So just keep that in mind. It's pretty cool. It comes in handy. All right, so we have our answer now. When you're solving equations, it's always good to form the habit of doing a check so you can be confident that your answer is accurate. All right, so let's do a check. I'm going to plug in k into my original equation and see if I get a true statement. All right, so I'm going to go 2 plus 5 parenthesis. I'm going to put in the result I got, which was negative 4. Put negative 4 here. Equals 3 parenthesis negative 4, and then minus 6. All right, what on earth just happened? You see this original equation here? I just took negative 4 and I put it for this k and that k right there. All right, so that's all I did. I'm doing a check here by substitution. All right, let's simplify. If we get a true statement on both sides, if we get a true statement, then we'll be good. Okay, so let's solve this. So this is going to be 2. Now when you're multiplying, if the signs are different, you always have a minus. All right, what is 5 times 4? 20. Now signs are different here, you're also going to have a minus. If the signs are the same, you always have a plus. Okay, so 3 times 4 is 12 minus 6. Now are these two numbers the same? What is 2 minus 20? Signs are different, so you're going to subtract and keep the sign of the bigger one. Okay, so you're going to subtract these two. 20 minus 2 is 18. Which is bigger, 2 or 20? 20 is bigger, so you keep the minus. Bam. All right. And then these two, notice that the signs are the same. If the signs are the same, you add and keep the sign. So what's 12 plus 6? 18. Since they're both negative, they're both 18. Okay. Since they're both negative, you have a negative here. So excellent. Our answer works. Since we did a check and it works out, we can be confident that our result is accurate. So the answer is k equals negative 4. All right. Okay, let's go ahead and try another problem. Now, when I put up a problem, what you can do is you can pause the video and try it out, see if you got it. If you get it, then you can move on. Or if you make mistakes, you can just watch my explanation and see where your mistake is. Okay, so now let's try the example 8x minus 2 equals negative 9 plus 7x. Okay, so remember the goal is you want the variables on one side and the constants on the other side, and then you want to combine like terms. Well, we like to do that simultaneously. We like to move variables and constants to the same side and combine like terms in the process if possible. Okay, so let's do that here. I want my x's on the left, my numbers on the right. It doesn't matter where you do it. You're still gonna get the same answer. But I like to keep my x's on the left. It's just a personal thing. So I need a 7x on the other side. Since this is positive, I'll do the opposite, minus 7x. And then make sure you line it up with the x right here, minus 7x. These are like terms because they both degree 1. Okay? And then I need this minus 2 on the left. You know where I want it? I want it on the right. So I'm going to use the opposite of minus 2, which is positive 2. So to preserve equality, whatever you do on the left, do it on the right. This is a number, so we're going to put the number under a number so that they're like terms and we can combine during the whole process, okay? All right, so if I combine these two, this is going to help me move the variables to one side, constants to the other side, and combine like terms. All right, so let's do this. How do we combine these two right here? Notice the signs are different. If the signs are different, you subtract 8 minus 7, 1x, and the sign of the bigger one wins. 8 is bigger, the sign is positive, so my answer is going to be positive. These two are opposites, so they cancel out. What is negative 9 plus 2? Signs are different, so you get to subtract. Subtract 2 from 9, you get 7. What is the sign of the bigger one? Negative, so you're going to have negative 7. These two are opposites, so they cancel out. So if you have one as a coefficient, it's like the invisible number, you can ignore it. You can just have x equals negative 7. All right, is my answer correct? I have no idea. I have to do a check. All right, it's good practice to check the accuracy of your solutions. All right, so what I'm going to do is I'm going to take x and I'm going to plug it into the original problem. Let me rewrite the original problem here so you don't get confused when I start my substitution. Now, another good practice is anytime you're making substitutions, always use parentheses, okay? So I'm going to go 8, parentheses, negative 7. Wrong color. I'm going to use the green, 8, parentheses, negative 7. Close that. Minus 2 equals negative 9 plus 7 times negative 7. All right, so what did I just do? All I just did is I took this 7, negative 7, and I plugged it into the x's in my original equation, okay? If I get a true statement, then my answer is accurate. So let's multiply this. 8 times 7 is 56, negative 56. Anytime you multiply numbers with these different signs, the sign is always minus, okay? Minus 2. And then minus 9. Positive times negative, signs are different when you're multiplying. It's always negative. 7 times 7 is 49. All right. Now, if you take a look at this right here, the signs are the same. So that means you add the numbers and keep the sign. 56 plus 2 is 58. They're both negative, so you keep the minus. On this side, signs are the same. So you're going to add 9 plus 49 is 58, and you keep the sign negative. Negative 58 is equal to negative 58. Excellent job. Our answer is correct. So we're confident that our result is accurate because our check worked out. Okay? So there you have it. Okay, now we're going to up the level of difficulty slightly. We're going to work on problems that have parentheses in them. So we're just going to add just an additional a little layer of complexity to the whole process. Okay? So let's try this one now. Question number 3. What if we had the problem? Let's. If we had the problem 12 equals negative 4 times 6k minus 3. Okay. All right. So let's try this one. So for this one, you notice this parenthesis right here. All parentheses means is basically to distribute, okay? So this negative 4 will get distributed or multiplied by everything inside the parentheses, okay? So what I'm going to do is I'm going to take minus 4 and I'm going to multiply it with 6k. Take minus 4 and multiply it with negative 3, okay? So note that anytime you're multiplying, the sign goes with the sign and the number goes with the number, okay? So I'll bring down the 12. When I multiply negative 4 and 6k, this is a minus. What's the sign here? If there's no sign, the default sign is positive. Minus times plus, signs are different, so we're going to have a minus. 4 times 6 is 24, and then k. All right? Minus 4 times negative 3, minus times minus. Anytime you multiply and the signs are the same, is always going to become a positive, okay? 4 times 3 is 12. Now we've simplified this. We've got rid of the parenthesis, which is a nuisance. Now it's easier for us to do. So now what we're going to do is we want constants on one side, variables on one side. Notice you already have a constant here with no variables. You already have a variable here with a constant. So what if we just simply move this constant to the left? Okay? You could do the reverse if you wanted, but it doesn't make any difference. Okay, so what I'm going to do is I'm going to move the constant right here to the left. So to accomplish that, this is plus 12. I'm going to subtract 12 from both sides. Subtract 12 and subtract 12. Okay, because this is positive, you have to do the opposite to get it moved over. And but whatever you do to one side, you do to the other side. Now we're going to combine these two expressions right here. All right, so minus 12 plus 12 is 0 on that side, and then this becomes negative 24k, and this also cancels out because they're opposites. Okay, now don't panic. To finish this off, all we just have to do is we need to isolate k. What is the relationship between negative 24 and k? Is a multiplicative relationship. So to undo that multiplication, we just use the opposite of multiplication, which is division. So negative 24, divide both sides by negative 24. All right. So on the left side, on the right side, this cancels with that. You're left with k. On the right side, if you have nothing and you give nothing to 24 people, what do each and every one of them get? Nothing, right? So 0 divided by any number other than 0 is simply 0. All right, so using the reflexive property of equality, I know that k equals 0. All right, so is my answer correct? I have no idea. We're going to do a what? We're going to do a check. All right, let's do a real quick check so that we're confident in the accuracy of our solution. All right, so let's do a check. We're going to plug in our answer into the original problem. So we're going to have 12. Is 12 equal to negative 4 times 6, parenthesis 0, minus 3? If I simplify this, do I have a true statement? So it's 12 equals negative 4. We're going to use, please excuse my dear Aunt Sally, PEMDAS, to do the, we're going to deal with we're going to deal with the parentheses first, okay? Simplify everything before we multiply, right? So parentheses first. So to do that, 6 times 0 is 0, minus 3. And then 12, negative 4. Now 0 minus 3 is just negative 3. And then negative 4 times negative 3 is negative, I'm sorry, it's positive 12. Wow, I'm scared. It's positive 12 because anytime you're multiplying and the signs are the same, you always have a positive, okay? So 4 times 3 is 12. There's something called slash and dash. Anytime you're multiplying minuses, you just slash and dash. Bam, bam, you have a plus like that. Oh, wow, our answer, our equation is true. 12 equals 12. So what does that mean? That means that our answer is correct. Okay? All right, now we're going to do two more problems. These are called special case problems. Whenever you're solving equations with variable on both sides, um, there are two special cases that you can come up with. Okay, they might look anomalous, they might look scary and weird, but it's perfectly fine. It's as a result of the fact that you have variables on both sides. Okay, so keep in mind the fact that this uh, special cases could happen. So be ready for them and don't panic when they happen. All right. Okay, so I'm gonna do a problem first and then explain to you how to classify your special case solution. So what if I had 5m plus 3 equals 5m minus 1? Okay, so the goal is to solve and check. So to do this, I want the variables on one side and the constants on the other side. So I need this 5m to the left and I need this 3 to the right. So to do that, this is positive 5 right here, right? So I'm going to subtract 5m, line it up with this 5m so I can combine them while doing the whole process. And this positive 3 right here, I need a constant on the right side, so I subtract 3 from both sides, like this. Okay? Now, let's combine. We're going to combine downwards. Combine these two downwards. All right. Now, if you notice, these two are opposites. The signs are different, but have the same magnitude. So if you subtract them, you get 0. So this cancels out. Minus 3 plus 3, these are opposites. They cancel out also. So you have a 0. And if anytime numbers cancel out, we have a 0. And this side, these are opposites. They cancel out also. Now, these two numbers are the same. I mean, these two signs are the same and the numbers well, the signs are the same. So if the signs are the same, you add and keep the sign, right? So 1 plus 3 is 4, negative 4. Wow, this is a problem. You know why? Because the variables are gone. So this is the case. This is the deal right here. Anytime your variables disappear, you ask yourself, is my result true or false? If if the statement is true, your answer will be classified as being infinitely many. Infinitely many solutions. That's what you say. All right. If your statement is false, you simply say no solution. All right, that's what you say. All right, so let's take a look at this situation right here. Is 0 equal to negative 4? If I have no money in my account, is it the same thing as owing $4? Absolutely not. This is a false statement. So if you have a false statement, this one you just simply say no solution. Okay? Another fancy way of writing it is the empty set. No solution. Okay? So this one means no answer that you pick will work. There isn't any answer. If you graph these two lines, what you're going to end up is you're going to end up with two parallel lines that never intersect. Okay? All right, let's try another special case problem, number 5. What if we have the following situation? What if we had 3 times 2b minus 1 minus 7 equals 6b minus 10. Okay? What if we have this? So what we want to do is, let's see. I want to get rid of the parentheses first by distribution, and then we can go on from there. So whenever I have the parentheses, we're going to deal with that first. So I'm going to distribute the 3 to this term and that term. So when I do that, I'm going to have 3 times 2 is 6b, minus 3 times 1 is 3, minus 7 equals 6b minus 10. Okay? So notice that these two are like terms, so I can combine them. So I'm going to have 6b. Since the signs are the same, I'm going to add and keep the sign. All right, so 3 plus 7 is 10. Keep the minus. Equals 6b plus minus 10. Okay, notice I got rid of the parentheses. I combine like terms here. Um, Now, what I'm going to do next is I need the b's on the left. I need the numbers on the right. Okay, so let's make that happen. To move this 6b to the left, I subtract 6b from both sides because this is a positive and the opposite of positive is negative. When we're subtracting 6b from both sides, we want to line up like variables, okay? And on the left side, I have negative 10. I need it on the right, so I add 10 to both sides. Add 10, add 10. Okay? Now, let's combine it. Okay, so now if you take a look at the left side, these were opposites, so they cancel each other out. These two, well, they're opposites too, so they cancel each other out. So you're going to have 0 on the left. On the right side, these are opposites, they cancel each other out. These are opposites too, they cancel each other out, so you have 0. Now, this is a special case. What makes it a special case? Because the variable is gone. Anytime your variables disappear in action, they go MIA, you have a special case. So you ask yourself, anytime you have a special case, you ask yourself, is the resultant statement, is it true or is it false? Is 0 equals 0? Yes, this is true. If your result is true, or if your resultant statement is true, then you have this situation, infinitely many solutions, okay? So you're going to have, this one's going to be infinitely, scroll it down a little bit, infinitely many solutions, okay? So what on earth does that mean? What does it mean to have infinitely many solutions? It basically means that anything you plug in for B will work. Okay, that's what it means. If I graph these two lines, you're gonna have two exact lines overlapping each other, which means they intersect forever for eternity. So that's when you have infinitely many solutions. So thanks so much for viewing this presentation. Please subscribe to my videos for future updates, and also feel free to request videos if you have any questions or things you like me to do. I'll try my best to make a clip for you. You can find a collection of more clips at madgoodsurf.com. Thanks again and have a wonderful day.